Okay, here we are in our last podcast of the unit, talking about density on page 17, and it's just going to be the top of page 17 here. We'll do the practice and review in class next time. So, what is density? A very technical definition is that it is a ratio of mass per volume. A little bit better kind of everyday definition is that density measures how tightly packed our matter is. So it compares that mass, how much matter we have, with the volume, how much space it takes up to get this ratio of mass to volume. And we've talked about solids, liquids, and gases before, and they do generally differ by their density. Solids tend to be the most dense form of matter, with their atoms really close together, moving really slowly, and as they start to speed up, they spread out in our liquids and even more in our gases. Now, the formula for density is simple, and you don't have to memorize it. It is always going to be given to you. D, density, equals m over v. And m is our mass, which is always going to be measured in grams. V is volume, which is generally measured in milliliters, but sometimes you might see some centimeters cubed given to you. That's still a volume. And then, of course, those are equal to each other. There's no conversion needed. There's basically the same unit. And then we have our density, and, D is density, but the units for density seem a little bit weird. They're combined units. There's grams over milliliters or grams over centimeters cubed. And while that might seem a little bit complicated, if you look at the units we have here, where we're dividing mass over volume, well, that's just the mass units over either of the volume units there. So it's just combining together the units from the numbers that we're combining together here. And density can be solved for on its own. And anytime you're asked to solve for density, use this equation. It's going to be given to you. But if you're asked to solve for mass or volume, you're either going to have to rearrange this equation, or you can use density as a conversion factor in order to do it using dimensional analysis. Now, some people like it, some people don't. I'm going to show you that process in the second example where we're not solving for density, and you can decide whether you prefer the equation way or the dimensional analysis way. So, one of the options for how we would solve this problem if we're not asked for density would be to rearrange this equation. And one of the tools that I think can help students to rearrange equations is a triangle. If you split this triangle up into 3 pieces like this, with 1 on top and 2 on bottom, you'd fill in the part of the equation that has more than one variable on it. So m is over v, so we put m over v in our triangle, and then put our density in the last space there. And the way that we would use this, if I'm trying to solve for something like mass, then you would actually physically cover up the mass part of the triangle with your finger, or here I'm just kind of whiting it out. And what's left behind is your equation for mass. So the d and the v are left right side by side here. So d is going to be multiplied by v in order to solve for mass. If I was looking for and trying to solve for volume, well, then I'd cover up, put my hand or my finger over the v side of things, and what we're left with is m over d. So m would be divided by d if we're trying to solve for volume. So you might have to rearrange this equation. I'm not going to give you all 3 of these variations on a test or quiz. You're only going to start with the original density equation, and you can either use your algebra to rearrange it, which still works, and I can help you with that in class if you need, or this triangle can help you rearrange it. Now, before we get into those calculations, a quick note about density. For a specific substance, density is constant as long as it's under the same conditions. We already talked about if it's a solid, liquid, or gas, the density is going to change. So liquid water has a different density than steam or ice. But if I have some substance like gold, as long as it's under the same conditions, temperature, pressure, stuff you don't really need to worry about, gold is always going to have the same density, no matter how big or how small of a piece of gold you have. It's one of the ways we can identify different substances is by that unique identifiable density. Now, keep this in mind, because no matter how small you make these pieces, if you have a big piece of gold and you cut it into 2 pieces, the density is the same. Because remember, density is how tightly packed our matter is, how close or far apart the atoms are. I'm not talking about how close or far apart those 2 pieces are from each other. The physical atoms aren't getting any closer or farther apart when all you're doing is cutting off a piece. And we could put numbers to it. If I say this original piece weighs 30, has a volume of 10, then 30 divided by 10 gives us a density of 3. Even when I cut that in half, my mass is half as much, so it's 15, but my volume is also half as much. So when I do 15 divided by 5, that gives me a density of 3 for both pieces. So you're probably not surprised that those smaller pieces have the same density because I cut this in half, but they have the same density as the original piece as well. So getting into the actual calculations here. Our first question is asking us, what is the density of an unknown metal that's measured 53.4 milliliters? That's a volume because that's in milliliters, and 3682 grams. Notice it doesn't tell us that this is a mass of 3682 grams or a volume of 53.4. We have to use our knowledge of units to be able to identify which is which. So we are solving for density, so according to our equation chart, D equals m over v. Density is mass over volume. So we just need to take the mass divided by that volume. So 3682 divided by 53.4. If you put that in your calculator, you'll get an unrounded answer of 68.9513. Then we need to round this based off of these numbers we're putting together into that density. And our mass has 4 sig figs, our volume has 3 sig figs, so our final answer needs to get rounded down to 3 sig figs. We want to keep the 68.9, but the 5 is going to round the 9 up to a 0, which will then pass that 1 on to the 8, so that becomes 69.0. That's our 3 sig fig answer. And of course, it would need units, grams per milliliter, G over ml. So hopefully that's not too hard. Let's look at the next one. This one says the density of gold is 19.3 grams per milliliter and asks what is the volume of a 15.5 gram sample. So those grams must be our mass. So here we're solving for volume, and we can either use that rearranged version of our equation, or in just a moment I'll show you the dimensional analysis version. But if you can rearrange that equation, it is pretty simple, just to plug in that mass divided by our density. And in our calculator, we come up with 0.803108. This time, both of our numbers in the problem agree. They both have 3 sig figs, so our answer is going to have 3 sig figs, so 0.803. And since this is volume, this is going to be in milliliters. Now, if we want to try and use density as a conversion factor, what you need to key in on is that density, that 19.3 grams per milliliter, means something. That means for this gold, there are 19.3 grams per milliliter for every milliliter, which means 19.3 grams is equal to 1 milliliter of gold. So it's basically turning that slash sign into an equal sign, or kind of pulling it apart. It almost kind of turns into that 1, and you put an equal sign between either side. And with that, we would actually start with our grams, our mass, the part that isn't a conversion factor. That's your given. And if we're doing this with dimensional analysis, if I've got grams on top, I'm going to take the grams part of that density equation, that conversion factor, put it on the bottom, keep that diagonal rule true, and then the 1 milliliter will fill in the top. Which means, just like in the last problem, we're doing 15.5 divided by 19.3. You might push times 1, it's not going to change the value at all here, but we're still going to get 0.803108, which we would still round to 3 significant figures and add milliliters to. So either way you want to work it out works for me, because we get exactly the same answer. Just helps to not have to rearrange the equation, but you do have to kind of rearrange that density value and kind of visualize it as an equation, even if you don't write it out in equation form. So, next problem asks us to find the mass if we have 32.5 milliliters, that's going to be a volume because that's milliliters, of sulfuric acid if its density is 1.83 grams per milliliter. So we're solving for mass this time, so we're going to be multiplying density times volume. And it doesn't really matter which one comes first because it's going to end up the same way, but our density is 1.83, our volume is 32.5, and when we multiply those together, our unrounded answer is 59.475. which if we round it to 3 sig figs, once again, we've got 3 sig figs in both numbers, so that'll be 59.5. Our units for mass are grams. One last problem here. Our piece of metal has a mass of 147. It's finally being nice and telling us the mass is this number. But keep in mind, just like some of these other problems we've been seeing, you might have to tell whether that's a mass or a volume just by its units. Now it's placed in a 50 ml graduated cylinder. That doesn't have anything to do with our number. We're not going to use that 50 anywhere. That's not going to be involved in our calculation. Now this is a little different because it mentions that the water level rises from 20 milliliters to 41. So those are two different volumes there that are talking about what my piece of metal does in that cylinder. But if it's going from 20 to 41, when I put it in that cylinder, that means the volume of my metal has to be 21 because it's the only difference between that volume of water before and after in the cylinder. So the difference between those two numbers gets me the volume of my object. And then we're looking for density, so this is just a normal mass over volume. Don't try and use dimensional analysis to solve for density. We've got an equation for that. So we're just going to take our mass divided by our volume, and even though our calculator is going to tell us it's a nice even round 7, keep in mind our original numbers had 3 sig figs for that mass and 2 sig figs for the volume. So we need our answer to have 2 sig figs. So 7.0 would be your full credit answer here, of course, with our density units on it, grams over milliliters, grams/milliliters. So hopefully that's not too bad, and that is the last bit of notes for this unit.